Okay. I have a news for you. Good, bad, and scary. So let's go to the first news. I've seen that I've set the solution to quiz number 4. Do you have any questions about it? How many of you think it was a fair quiz? Okay, good. For those of you who don't think so, that might not really matter because I think it was fair. So, what was that? No, I think everybody is gonna get a full grade. I think so. That's supposed to, because we basically solved all the problems together last time, so it shouldn't be any problem. I mean, you know how to solve it yourself, so, and you had plenty of time, so I'm sure we are going to see a very skewed distribution of grades toward full grade. So I have the 3 solutions, but let's have a look at them quickly, because I think the most important one is the vectorized version of the code. So what did we want to do? We wanted to write a function that takes n and then calculates n factorial. So the while version of it, let's go to the for loop first. So I define a variable called factorial, or fac, and I set it to 1. Then I say for I equals 2 to n, factorial equals factorial times I. So why do I initialize factorial to 1? Why not some other numbers? Any ideas? Exactly. So if I set it to 0, what do I want to create? I want to create this sequence from n to 1. So what I'm doing here is that I'm going backwards. I set factorial to 1, and then I multiply factorial 1 by 1 with the bigger numbers in this sequence. So I go from 2 to n, and then multiply each time update the value of factorial with the new value, right? Could I set this to anything else other than 1?
Yes.
Yes, good.
If you change the sequence below.
Exactly. So I could say n, and then start from n minus 1, and then go in the negative direction up to 1, but 1 doesn't matter, so we could make it 2. Yeah. So that should also work. Or I could set it to anything I want between n and 1. But then you will have to add an if block here and say, if factorial is that number, don't multiply it by itself again. So that's it. So that's how the for loop works. But let's have a look at the while loop version, which is a little bit more difficult because you need to define the iterator here that you had by default with the for loop manually here. So in the while version, I start from n actually. I could have started from 1, but doesn't matter. It doesn't make much difference. So I say factorial is n initially, and then while n is larger than 1, set n to something to 1 unit smaller, and then multiply it by the current value of factorial to get the new value. So basically, I start from this side again. I say initially factorial is n, and then multiply it with the next number, with the next smaller number, with the next smaller number, and so on until you hit 1. Okay. So the difference between the while version and the for loop version is that here you have the index naturally for you, for your calculations. So I is automatically updated at each iteration of the loop. But here you have to update the value of n manually. Okay. So that's a while loop. And then let's have a look at the vectorized version, which is really my favorite because it's just one line. What am I doing here? How many of you got this part correctly? Okay, good. Okay. So what does a prod function do? Multiplies numbers, right? what does n to 1 mean? 1 to n, I'm sorry. So I would say 1 to 10, it's going to give me a vector of numbers from 1 to 10. If I wanted every other number, not exactly the whole sequence, how could I get it? Like if I wanted the even numbers or odd numbers. Yes, I would say 1 colon 2, 10. That gives you the odds. But if you wanted the even numbers, you could start from 2. That gives you the even numbers, right? So it doesn't matter how you construct it. So here we want the full sequence. So I don't use any skip step size, any step size here in between 1 and n. So I just say go from 1 to n, and then prod just multiplies all those elements in this vector together. So if I say prod of 1 to 10, it's going to give me this number. Is this too small or you see it well? Phones. Okay, so if I say prod 1 to 10, and then if I say factorial of 10, that's going to give me exact same number. Okay. Now, how about the timing part? Any questions about the timing part? It was really easy because all you need to do is to display this text and then use time mid function. But then again, time mid function takes a function handle, not the function itself. So you pass the function handle to get fact_while, get fact_for, and get fact_rec. That's it. But the most interesting part is this last one. Did anybody get this part done?
After the actual time.
After time, okay.
Yeah.
But okay, that's good. But I hope you didn't hear it from our discussion here. If you didn't, then that's impressive. So for this part, really what you need to do, so I asked you to use sum instead of product function. So here you have prod, right? So I said do some transformations on the vector that you have so that you can use sum instead of product. So what I could say instead of this line is something like this. I could say fact equals sum of. So remember, if I take the log of a variable, two variables that are multiplied by each other, you get the sum. So if n factorial is this, if I take the log of n factorial, it gives me log of n plus log of n minus 1 plus to the n and then log of 1. Okay. Now, so what I can do is that I can, instead of calculating this multiplication, I can calculate this sum, and then in the end, invert the result and get the exponential of log of n factorial, which gives me 1. What? So if I say, what is the result of this calculation? N factorial. What is this? It's just n factorial, right? Okay, so all I need to do is to get the log of it first, and then sum over log of the variable. So I would say log of 1 to n. Okay, this gives me the log. So this is the log. This is the log of this is the log of n factorial. Okay. Now I'm going to display these two numbers and show you what the difference between them is. So this is factorial using product, using prod. What am I missing in this display function? I'm missing what? I'm missing a function there. exp of fact. I'm missing something. Nobody? num to str. You need to convert your number to a string, otherwise it will not work. So, and now we have the factorial using sum. And we're going to see what the difference between them is. So it's on desktop. So if I open this, go to desktop. Okay. Better close this one. And then, okay. So let's run this. Right now. Get wake n or 10. Let's try it with 10 and see what we get. Okay. So you see both of them give you the correct answer, right? But there is a problem here. So this method is very useful, and in fact you're going to use it in your semester project. This method that I told you, to take the log of the variables and convert a multiplication to a sum. Because sometimes, for example, factorial can become really huge number. If you go to like factorials of 200 or larger than that, you see you get an infinite. So why does this happen? Why do you get a factorial of 200 to the infinite? You hit the end of the maximum possible representation for the real numbers by your computer. So the biggest number that you can represent by a double precision number is around what? Ideas? 10 to the power of 3 to 10 to the power of 308, I think. Close to that number. Let's try it. So we could say real max. That's a number. So if the result of this factorial, if the result of all these multiplications is larger than this number, then you will not be able to get the correct answer. So what's the solution for these sorts of problems when your number is too big to be represented by your computer? The solution at these times is to take the log of the variable and use the log value instead of the value itself. Because you can always represent an extremely large number by its log. So if I take the log of real max, log of real max, you'll see that it's a very small number, 709. Okay, so if I say, that's going to be big. So if I said, what is real max to the power of 2, gives you infinite. But the same thing, if I first take the log, and then basically what happens to exponent when you take the log? It's like multiplication, right? So it becomes a sum, basically. So it's like you're adding 2 log real max to itself. So this would be the log of this number here, which is quite representable. So you can use the log representation to get a meaningful representation of the number you want, right? And you will use this in your semester project. But what's the relevance to this one? So for example, here you know that if the number goes beyond 200, or what the number, I'm not sure. So let's see, factorial of 170. That's still meaningful, 71. Okay, so if the number is larger than, so you could say this. If n is larger than 170, then report the log of it instead of the factorial value itself. So you'd say, if it's less than 170, use the correct representation, else represent the log of it. So log factorial, and this is factorial. And then you don't need this last line. Okay. So that's how it works. Now, if I try this function again and say, what is get factorial of 10, it's going to give me the factorial of 10. But if I say, what is the factorial of 1000, it's going to say, this is the log of the factorial, because the factorial itself is not representable by double precision numbers. Okay, so that's a very useful representation, and you should keep it in mind for future. But let's get to the scary news, which is the project semester project. And I have it. So it has three main sections, this project. And our goal is really to do a real research project. So this is really what people do in the Center for Computational Oncology at UT Austin. Not exactly this, a little bit more complicated than this, what you're trying to do here, but the flow of the work is basically the same. You have a set of data, and then you have to analyze it, reduce the data, clean it up, and then make graphs of data, and then finally model the data using some hypothesis you have. So the flow of scientific inference is always like this. You go observe something in the nature, and you see, for example, something has happened, and then you collect information about that phenomenon. You make a hypothesis based on that observed phenomenon. So you say, for example, I'm guessing, so like, for example, you look at the distance and you see an object moving. And based on your information and your prior knowledge from zoo, you say it's probably mule. And your friend says it's a donkey. So you have two different hypotheses. You have to collect information. So what you do is that you bring a good camera and take photos, and then analyze those photos, and then check your hypothesis, which one is correct, right? So that's basically the flow of scientific inference. So based on those observations and your hypothesis, next time you see an object moving in the distance, you would say, well, I'm confident that it's going to be a donkey or a mule or something else, right? So it's the same thing here. Instead of having an object moving in the distance, now here we have a tumor in the brain of a rat. And the goal with this experiment is to figure out, how the tumor grows in the brain of a rat, and then if we add chemotherapy or radiation for this tumor, how is it going to affect the growth of it? Okay, so I think maybe I could show you a better representation of this. Let me. Right. So it's something like this. So if you have a rat, and then we inject tumor cells to the brain of the rat, and then let the rat heal for a few days, or like 10 days almost. And then starting at day 10, people put these rats in an MRI machine. It's called magnetic resonance imaging. So what this does is that it creates a full scan of the brain of the rat, and it says how many tumor cells we have in the brain of the rat. So it's something like this. So if this is the brain of the rat, the MRI machine creates slices of this brain, hypothetical, so it's not real slices. So it's just imaging slices. So it creates 16 slices of this brain. And each one of them, so you see this is 16 slides, 4 by 4, right? And Z1, that subplot there, corresponds to this one here. And then this is Z2, Z3, Z4. So if there is nothing in the first 6 slides, what does it mean? So these areas are tumor. So this shows the number of tumor cells. If it's yellow, it means a lot of tumor cells, according to this color bar. And if it's blue, it means almost nothing. So at the bottom, if it's complete blue, it's 0 number of cells. Okay. So if there is nothing in the top subplots, what does it mean? It means those slices are completely okay. There is no tumor cells in them, right? So from slice 9 to 14, there is probably tumor cells in them, right? We cannot really represent it in 3D because it's really difficult. So that's why we created slices of them and put them all together in a 4x4 subplot. Okay, and then we can visualize it. Now, this is only day 10. So remember, we injected the cells at day 0, and then let the tumor cells grow. And this is day 10. At day 10, we make an imaging, and this is the output of the imaging, right? So if we count the number of pixels, each pixel in this figure is called a voxel. Okay, so if you see the word voxel somewhere, yes, voxel number, it means just one pixel on this figure. Okay, so in each tiny voxel that we have, which is really tiny, this MRI machine can tell us how many tumor cells or how many healthy cells exist. Okay, so if there's healthy cells, it set them to 0. It doesn't matter for us. We want to count the number of tumor cells. So basically, by counting the number of voxels and how many cells, tumor cells, exist in each voxel, we can find the total number of tumor cells at this time, at day 10. Okay, is that understandable for you guys? Okay. Then we go 2 days ahead. In day 12, you see the tumor has started to grow more, and you see some division here. So we have different numbers of cells, different positions. So we go to day 14, and then 16, 18, and 20. It gets really huge. Okay, so at each time point, at each day, we can count the total number of voxels that contain tumor cells and add the number of cells, tumor cells, in each one of them to get the total number of tumor cells in the brain of the rat at that time point. Okay, so one of the goals in our work is to create these plots, because these plots were all created in MATLAB, and it's not that difficult. So all you need to do is to learn how to use subplot, and we are going to get to plotting probably on Friday. So you will know how to plot things in MATLAB, and it's really cool and fun, because MATLAB is really great for plotting. So our goal is to create plots of this data. So we have a data set at the beginning called cells. I give you this data file. It contains all the information in coordinates x, y, x, z, and time. Okay, so we create these plots, and then at the end, we also count the number of tumor cells in each day. So we can get the total number of tumor cells in time, something like this. Okay, and now here is our hypothesis. We are hypothesizing that this growth that we observe here is well described by a Gompertzian function. So what is a Gompertzian function? It's very much like exponential, except that it is actually double exponential. So what is the form of Gompertzian function? It says the observed number of tumor cells in the tumor should be proportional to the initial number of tumor cells, which is 100,000, and it's given in this project, times exponential of some parameter lambda times 1 minus exponential of some other parameter c times t. T is time here. Okay, so if I plug in time 10 equal 10 days here, and then I know c and lambda, and I know also n0, the initial number of tumor cells, then I can find how many tumor cells I have at that time, at that date, on that date, given this information, given the parameters of the model. But the problem is that we don't know the parameters of the model. We don't know lambda, we don't know c. So our goal is to find these two parameters through some algorithms in MATLAB. So for example, suppose you have a function, you want to find its maximum or minimum. You can use these sorts of minimax function optimization algorithms to find the best fitting parameters of your model. Okay, so we're going to have a lot of discussions about this project over the remaining lectures. So don't panic about it, but this is basically an outline of what you're going to do. So there is a little bit more work in this part. So you need to define a cost function for your model and then find the parameters that lead to the least cost, meaning that it leads to the best fit to your data. So once you define these functions, which is really easy, and I have told you already part of it, you take the log and you just modify it. So these are all just equations. You can put them in your in the form of a MATLAB script and then solve the problem. And at the end, you have this function, MATLAB function, called fmin_search. So you ask fmin_search to optimize your function and find the parameters that give you the best fit to your problem. And this is the final result. So this is, by the way, wrong. Apologize for that. So the comparison fit is the red curve, and experimental data is the blue curve. So I think it's a good fit at the end, right? The rat died, unfortunately, but we could still use the information for future. Because there was no treatment. So we could have the other cases where we add, for example, treatment, we add radiation or chemotherapy to this rat, and then see if it affects the growth of this tumor. It lowers it, for example, it makes it flat, or it shrinks the size of the tumor in time. Okay, so this is basically it. But this is a tremendous work. It's not for one single person. So you're going to work together in groups and teams, and for that purpose, now we'll get to the sad part of the news that I had for you, which is I have posted the next homework 5. And the first question in this homework is about creating groups for yourself randomly. So we're going to assign 3 people randomly to each group and then work together. So how do you do this? I'm going to get to this in full next time, but for now I'm going to tell you briefly how you can solve this problem. So what do we want to do? We have a list of students, this CSV file. I hope I can open it. Yes, no, okay. So there is, I think we could, but it doesn't show it in a formatted way, sadly. So, but it still can understand it. So I have created an ID for each student, which is basically just a number assigned to you, and then the student name. So we have Ashok at the first student, and then so on. We go to the end, and we have 99 students. One of them doesn't exist. So, but we need it because we want to have groups of 3 people. Okay. So one team is going to have 2, but they're going to have 2/3 of the work, because the work is really modularized. So your goal is to find. So let me talk about it, but let's define the groups. So how do we assign randomly people to each group? It's a difficult question, so I don't expect you to know, but let's do it together. What was that? Yes, you can use random number generators, but you don't even know about random number generators. How many of you know what random number is? Okay, great. So basically, a random number, when you talk about it, is just a number between a given interval. So I say, give me a random number between 0 and 1. What do you give me as a number between 0 and 1? No, 0 is not a good choice. MATLAB doesn't give you 0 or 1. 0 or 1. It gives you something between. So it could be 0.4, for example. What other numbers? Could be 0.6. Now, it turns out that if you ask people in the street and say, give me a number, random number between 1 and 10, they don't do it randomly in their mind. Even though they think they will do it randomly, they have preference. So people have done this experiment, and they have noticed that if you ask people, give me a number between 1 and 10, most of them choose, as far as I remember, 6. which means that they are not doing things randomly in their mind. They think that you are doing it randomly, but it's not random. And that's a tremendous problem, even with computers. Even though, for example, let me create a random number here for you. If you want to create a random number in MATLAB, it's really easy. All you do is this, CLC, and you say rand. This is a random number between 0 and 1. Okay? Now I can say give me not just 1, give me 10 random numbers. So 10 rows and 1 column. And it gives me a vector of size 10 of random numbers. And all of them are between 0 and 1. Sure. How do you get a number between 1 and 100 instead of 0 and 1? Do you want integer or real number? Integer. Okay, so for that, MATLAB has simplified our work, our life. So I can say rand I, and I want it to be between, if I remember correctly, this should be the range. So I could say between 1 and 100. So it gives me, so if I say, give me one more, give me another one, 49, 81, 15. So each time is a different number. Okay, what was the question?
Why is the random number that you generated first the same as the one I thought?
Excellent, yes, very good point. Why is it so, really? It's because these numbers are not really random. They look random to you and to me, but there is really an algorithm behind it. There's been like 100 years of work. Really smart people have been trying to figure out how to create random numbers, but it's almost impossible. Because, see, how do you define a code? How do you define an algorithm? You have to have a set of instructions, right? So if you have a set of instructions to create a random number, that means if you start from the beginning, you're always going to get the same sequence of random numbers through that set of instructions, right? So you can never get out of this logical loop. Yes?
Aren't there some languages that do based on like timing? So
Yes, good point. So what's the solution? So we can make it a little bit more complex so that we don't get these sorts of questions in class that the random numbers are the same, right? So the solution is what? There's a function in MATLAB called RNG, and what it does is that it shuffles the initial seed. So the way these random number generators work is that you give them an initial number, and then they work with that number, create another random number from that, and then make it inside of the interval that you want, and then generate other numbers from that initial seed. Okay, but I can say set this seed to the time of the CPU, for example. Okay, then you will not have this problem. So try RNG shuffle, and then you'll probably get a different sequence. So let's try this, and then let's try this again. You see, now I'm getting a new sequence of numbers. So if you close your MATLAB and open it, and try rand I, you're always going to get the same number. Because the algorithm in MATLAB starts from the same initial seed number in the random number generator. But if you type RNG shuffle, then it's going to generate almost really true random number for you, because the seed is now dependent on the time of the CPU, which is different at each moment. Yes.
Oh, I know. I was thinking the shuffle be random.
Yes. Yes. So I could say, instead of shuffle, I could say set the initial seed to, I don't know, 13, 13, 13. Okay. Now let's try it again. Let's create random number. 34. Keep these numbers in mind. So I say RNG 13, 13, 13, and then rand I. You can set the initial seed to any positive number, positive integer number. Okay, so it should be positive. If I set this to RNG negative, it gives an error. It says the number should be between 1 and 2 to the power of 32. Okay, so RNG, and then I say rand I, gives me 34. Okay, try it again, 53. 96. Now let's try again and reset the seed. Now again, if I try random number, it gives me again 34. You see, so you reset the random number generator, it goes to the beginning of the sequence of random numbers, and it starts from there again. Okay, so this is really good. This is sad, but it's also very good, because most often in scientific programming, you want to write codes that are reproducible. So, for example, you run your code with a random number, and then you get some results, and then your colleague asks you, why did you get this result? I want to check your solution from the beginning. If the numbers generated each time are purely random, then you would be in trouble, because you can never recover the answer you got. But if you set the initial seed to a fixed number, then you can always generate the exact same results at the end. Okay? So, how do we create this list? Let's create this list before we leave, and that's the first problem in your homework. But I have also good news for you before we leave this class, which is a long time still. So don't be prepared to leave. I have moved the deadline for the homework to 29. So you don't need to worry about homework during the Thanksgiving break. Okay.
Wednesday.
What was that?
It's a Wednesday.
Yes, but the Thanksgiving is on
Monday.
Yeah.
Oh, okay, so it's fine.
Yeah, it's Wednesday.
It's confusing, but you get the message, right? It's November 29th. So I will fix it. Thanks.
It's due Monday or Wednesday?
It's due Wednesday. Okay, so it's due Wednesday 29th. Okay, but you should really start early, because this homework is kind of challenging, and you need my help. So you should really attend the class, or attend my office hours, or get help from the TAs for this homework. Yes.
Class tomorrow.
No, we're going to have a class on Monday, next Monday, but not on Wednesday. So Wednesday is an official holiday, university holiday. I wish we had, but we cannot.
A bunch of teachers are
If you're really in trouble, you cannot attend the class, and that's up to you. But since you have to stick to our schedule, I will be here, and if you can, we will have also the lecture notes, the lecture video, so you can have a look at it if you want it. Yes.
Are we doing quiz on Wednesday?
Yes. So the quiz will also be on Wednesday, November 29th, the same day as the homework is due. Okay. So let's solve this problem. So we want to create triples of these names. How do we create them? So there's a function in MATLAB called rand_perm. What it does is that it creates a permutation, a random list of integers between the numbers that you give. So if I say create a rand_perm of 99, what it does is that it creates a list for me that contains random numbers that are randomly placed in their positions, and all of them are between 1 and 99. So the first one is 85, 41, 62. So I don't know if you get the message now or not. What do we want to do? We have a list of names that goes from 1 to 99, and we want to create random triples of them together, right? The problem is that if you look at this list, it has three. We could just say, okay, these three people form the first group, these three students form the second group, and these the third, and so on to the end. But what's the problem with this approach? It's not random. It's all, if you look at the alphabetical order, you see it's all alphabetical order, right? So it's not really random. I don't want all the people with the same name to be in the same group. So we want to be as random as possible. So how do we do this? What we can do is that we have IDs for each of these people, right? So what I can do is that I can assign to each person how did it work? I don't remember how I did it myself. Let me pull up the solution. Pick student triples. Okay, that's what we want. So the first step you need to do for this problem is that the number of students is 99. So you have to use a function called read table. We have used it in the past, I think. We used write table, I think, in the previous homework. But another method for reading information from a file in MATLAB is read table. So what it does is that it can read CSV file and TXT file and also .dat extension files for you in MATLAB. So if I say student data is read table in this folder, let's see what happens. So let's see where we are right now. We are in desktop, which is not good. So we want to go to this folder. Okay, and we want to open PK student triples. Now, what we want to do is to run this code. Okay, now, okay, so what I did right now is that I read this table, students CSV, that you have also access to it in the problem, in the first problem of the homework. So you have the CSV file here, right here at the beginning. So you can download it, and then you can say read table this CSV file, the path to it, and then store the information in student data. Now let's look at the student data and see what it is. So student data is basically all the names, the ID and the names. Okay. Now I can access the information in this structure like this. I can say student data dot. It gives me the components that exist in this table, ID and a student. So I could say give me IDs, and it prints all the IDs for me. I would say student name. So it gives me all the students, including the last one, which is null. Okay, so we have the student list now. What we want to do is to assign these triples of these students random numbers so that they become groups. So let's see how we can do this. So I defined a triple vector called triple, and it's random permutation of the size of n students. So what does the rand perm does again? What do for you? It's a random permutation of numbers that goes from 1 to n student. What is n student? Is 99. Okay, so if I say, let's do it again here. Rand perm of 5. What do you think you would get? You get 5 random numbers that are between 1 and 5, but their order is completely random, right? So you get something like this: 3, 5, 1, 4, 2. Okay, so we could equally say 99 and get a vector of 99. Okay, and then I say I define a cell array for student names. So why is this cell array 3 rows and n student divided by 3 columns? Or yes, that's correct. Because we have a long list of 99 students, and we want to put 3 of them in the first 3 rows, next 3 of them in the second 3 rows, next 3 of them in the third 3 rows, and so on, and create a cell array that contains groups of students. So if we want to form groups of 3 students, what would be the total number of groups? 33, not 3. The total number of groups is 33 because we have 99 students, right? So we create this cell array which will contain the student groups for us. And then I loop over I from 1 to 33 to the total number of groups. And then I say student triple, the first group. So I is 1. So the people in the first group are going to be these people. Get the student with this ID, triple I. You see what I've done here? So I'm randomly picking student names from the list that I had. So each student has an ID here, right? So it's the first one. So the first one is Ashoka, as far as I remember. So each person has an ID according to its row in this list, right? But now I have created another list, which is random, this triple list, random permutation of 99, okay? And it's just random numbers from 1 to 99 randomly set in different places, right? So I can take the first 3 in this sequence, in this random permutation triple. I can say that the first 3, 86, 42, and 43, form the first group for this project. The students with ID 74, 5, and 44 form the second group. Okay, and then the students 17, 50, and 30 form the third group, and so on to the end. Okay. Now the only task is to find who is 86 and who is 42, who is 63 in the list that we had in this list here. So we need to match the IDs of the students here with the numbers here, and then output the result. Okay. So that's basically what we are doing here in this problem. So I say pick the student with the ID of triple I, pick the student with the ID of the next number in this triple sequence, and the next one, so on. And if you do this, then at the end, I can use another function for input-output. It's called XLS write. There is also an equivalent of it for reading, XLS read. What does it do? Any guesses? Excel, exactly. It writes an Excel spreadsheet for you. So I can say it takes a cell array and writes an Excel spreadsheet for you. Okay. So at the end, I say write the pairs of the triples of a student names in this Excel file, and it outputs the results in this file for us. Now you have access to this file yourself, so you can see who your group is at the moment. But here's the catch. If you run this code, if you wrote it yourself, you can learn it from this file, as it's okay with me if you want to learn how to do it. And you can also come to my office hours. I'll help you to write this yourself. But if you look at this file, you see that randperm is a random function, is a random number generator, right? So what do you expect? If you run this code multiple times, each time you're going to get a different answer, right? So each time you're going to get a different group, which doesn't make sense. So we want to stick to one set of groups. That's why I have set the RNG at the beginning to 131313, just a random number. You could choose anything else, but this is what I have chosen because it was November 13th. And that's the arrangement of the groups that we get with that random number generator. Okay. So there is one group here who is paired with what? Okay, let's see. Who is null? Okay, so Arellano, and then we had Seth. Where are you? Arellano and Seth. So we have, this is you? Okay, so you two have one null member in your group, which means that if you're okay with 2 members, then you can work with it. If you need more, then we can change it. But basically, the workflow, the workload doesn't make much of a big difference for you, because in the project, in the semester project, I have 3 sections. So I would recommend you to sit down. You can download this file, the list of students from here, from this link in the problem. Okay, and you can see who is your partner in the group. And then I would say determine a group leader for your group. If you don't know who exactly, just try MATLAB and throw random numbers. Assign yourself an ID and say rand I between 1 and 3. and whoever is one will be the leader, for example. Okay? So determine the leader and then divide the work between yourself in these three sections. Data visualization and the rest of the parts. I know, and Seth, I want to talk to you.
Our actual goals.
This is for the semester project.
Yeah, I'm saying like, where's the public? Actual groups.
Oh, the actual group.
Yeah.
The actual group is visual. It's on your GitHub project. So you determine one member who is the like sort of the leader of the group.
No, I'm saying like from that document.
Oh, the document is in the problem. So if you go,
The one who was in our groups?
yes, the one that contains the group information is here. This one.
That's the actual one.
That's the actual one. Yes. Seth and I don't know. Okay. So since you're two, I thought that you don't need to this section of the project. Does it seem too scary, guys?
No,
Okay.
I think we got it.
Okay, great, awesome. I'm happy to hear it. So if you look at this part, this table of content for the project, we have data reduction and visualization, which is to create these graphs. Okay, and then we have the mathematical model of the tumor growth, which is a little bit math, but if you follow the instructions that I have here, and also get help from me, because you will not be able to do it alone. So you need my help. Okay, then you'll be able to do it. But then there's a third part, which is to get the errors in the tumor cell count, these error bars here. And for this part, you don't need to do it yourself, because this is the job of the third person in your group, which you don't have it, and it's not needed for the other part. So the work is highly modularized. So you could plot things that you have here, completely independent of Seth's work, for example. You just choose yourself who wants to do what, and then the grading of the work works like this. So you have 4 points, or no, it's actually 25. So the project has 35% of the grade, right? 25% of it is for your own work. So you say, for example, we came up with this workload for each person in the group, and who did what. But then there's 10% work that goes to the completeness of the project. So you have to care about other person's work. If you see that he's lagging or he's not doing something correctly, you need to help him also. So that's the whole point of this work. They wanted to work together and help each other to solve the problem. And then one of you can be the person who maintains the project. So you could, you mention it, and then you give your name to me. So one of you can have the project in your exam folder, in your project, yes. And the other person, if you want to have it, that's fine. You could just branch it from, I don't know, this project, or
fork it.
you could branch it, yes, fork it from Seth's project, doesn't matter. So you could do it, and then at the end, just tell me who has the main project, so that I can have a look at it.
Okay.
Yeah. If you fork it, then you have identical copies, so it doesn't make much of a big difference. Yes.
Then you just do like a